charm, maybe. All right, I think I got it. The third time's the charm. Hello, everyone, and welcome in to my channel. I am Professor L, and I'm hosting a live stream for math engagement, math help, math tutoring, and just promoting a group study of math. Yeah, and so I'm opening up this space, my camera, and my board. So if anyone's out there and they want to do some math with me, then they're more than welcome to do that. In the meantime, I have picked a problem out, and I went ahead and got it on the board, and yeah, I'll just leave it up for a couple minutes and then I'll work it and try and just a slightly different strategy, trying to be a little bit more prepared. So this is the problem that I'm going to work here in a couple minutes. And so, yeah, I think I forgot my drink anyway. I'll get it. I'll come right back. Anyway. I'm having a little bit of a technical issue. I had to refresh a couple times to get it to when I was clicking on going live. So I think we're good. And yeah, so happy Tuesday. I hope everyone's doing well. And I just want to give a chance for the anybody that's watching that wants to read the question problem. And I'll read it also. As a strategy, when you're solving word problems, it's best to read it twice. The first time you're reading it, just getting a general idea of what the problem is saying. The second time you read it, you're looking for like relevant math language, like what the main thing that I look for when I'm solving a word problem is what is it asking me to do, to solve, and what is my end goal. And so I read it twice and I get a good idea of that. And then from there, I kind of start thinking about what the problem is, anything that it's telling me. And most often, every detail matters in a math problem like this, like word problems. So I'm going to read it once and then read it again. And what I'll do is I'm going to go ahead and pull out the language the first time. That way I don't have to read it twice on camera. But mainly what this is it's an introduction to matrices and linear algebra. It's a whole branch of mathematics contributed to solving systems of linear equations. And to be honest, I still have my linear algebra book and I'm kind of getting into that a little bit. So I think that probably that's something to anticipate the next couple live streams for sure, is getting into those. I want to remember all of those. There was a way to use the inverse matrix to really quickly solve, and you can solve for multiple variables using those matrices. So they're very handy, and yeah, it's a kind of somewhat of a forgotten skill for me. And so I'm looking forward to going back and revisiting that subject. Anyway, something to look forward to. And this is a very good introduction to matrices because basically when you have a system that you have more than one variable, you have to have more than one equation. And in fact, you have to have a separate and unique equation for each variable that you introduce into your system in order to solve it. I do not know necessarily how to solve 4 variables algebraically. The only way I know how to solve a 4 variable would be with the matrices. And I remember them not being so much fun, and augmented matrix operations and row reduction. But this problem right here will give a good introduction to, and I am very confident in solving up to 3 variables on using algebra. So that's what I'm going to do. All right, enough chit chat and running behind because of technical issues. So here we go. It says a team bus is carrying 15 players. Only sophomores, juniors, and seniors are on the team. There is one more sophomore than juniors. The number of seniors is one more than the sum of the number of juniors and sophomores. Wow, it's not probably not gonna, it's not a complete sentence. But I'm pretty sure I wrote it down verbatim, and I tried to have the problem organized before I clicked live stream. So it says how many juniors, and there should be a question mark. How many juniors? Well, it turns out that there are probably more than like one. There's probably multiple ways to solve this, but whenever I looked at this, I immediately saw 3 variables, 3 separate equations. And so I knew that I would be able to quickly find the solution. However, I wasn't able to find it without finding all 3. So basically, I had to find all 3 variables to find the juniors. So I don't know if that's just first glance. I just picked this problem out today. So anyway, yeah. All right. So we have only sophomores, juniors, and seniors, and we're looking for how many juniors. So I just called variables and I said x equals sophomores. And then y can be juniors. And then you've got z will be seniors. All right. And it says a team bus is carrying 15 players. And you know that there are sophomores, juniors, and seniors. So that gives me my first equation. The number of sophomores plus the number of juniors plus the number of seniors. And it all equals 15. And it says there is one more sophomore than juniors. So there's more sophomores than juniors. Then I can say that x equals the number of juniors plus 1. Because it says there's one more sophomore than juniors. So I know that that means the sophomores are going to be bigger. Okay. The number of sophomores will be bigger. So it's the number of juniors plus 1. And then I need one more equation because I have 3. Since I have 3 variables, I have to have a separate and unique equation for each variable that is introduced to the system. And so I can write another one. It says the number of seniors is. And so what I'm doing is I'm writing algebraic statements. I'm transferring the language into symbols. And is means equals. So I have seniors equals z. And the number of seniors is 1 more than the sum of the number of juniors and sophomores. So I have the number of sophomores plus the number of juniors plus 1. And that should equal my number of seniors. Okay. And so, since I have all 3 equations now I just have to figure out a way to solve them. And so that's what we're going to do. And yeah, so what we want to do is we want to be able to somehow, we can use substitution, or we can use elimination, or you can use a combination of both. You can add any 2 equations. You can multiply any equation by a scalar. A scalar is just a number. It could be a fraction, it could be positive, it could be negative, but you're able to multiply each equation, and you have these rules that you can perform on the system, and that kind of confines you to what you're allowed to do for basic math operations, but it's basically adding, subtracting equations, multiplying by scalar, and then adding any combination of those. So what I think I want to do is I noticed that we've got them equal, so I think I want to just put them all in like the same form in this general standard form here, and see if that doesn't help me. So I'm just going to rewrite x equals y plus 1. So I'm going to say x equals y plus 1, and I can manipulate this. I can subtract the quantity y from both sides, and that's going to give me x minus y equals 1. And I'll just box that for a minute because we'll rewrite them in just a second. And then I want to do the same thing here with this z. So I'm going to rewrite it. Z equals x plus y plus 1. So if I subtract x from both sides and y from both sides, I'm going to get negative x minus y plus z equal 1. Okay, and then I'll box that. And I have this one. So I'm just going to restate my system so that they line up. So I'm going to restate them. And I guess I can rewrite them just below here. So just cleaning it up a little bit and saying x plus y plus z equal 15. And I have an x minus y, and there's no z equals 1. And then I have a negative x minus y plus z equals 1 also. All right. And if I wanted to just have a placeholder, I could say 0z if I wanted to. And what I'm noticing here is I don't want to add all 3 equations, but if I add the first equation and the second equation, I won't have to multiply by any scalar or anything. I can just add them together, and I will eliminate x and y out of those equations. So that is my very first step that I'm going to do. I'm going to add x plus y plus z. Let me get out of the way. equals 15. And negative x minus y plus z equals 1. We're going to add those equations together. And you get 0 here plus 0 plus z is 2z. And 15 plus 1 is 16. So this is just 2z equals 16. So if we divide off the 2 from both sides, we can say 16 divided by 2 is 8. So we have solved for the number of seniors. And this is an ordered pair, x comma y comma z. So you'll write your solution this way. But it's only asking for your juniors. So we'll say 8. And so it would be x comma y comma z. And then we can, since we have z, what I can do, okay, so what I'm going to do is I'm going to take this equation right here, this original equation, and I have z equals 8, and I have x equals y plus 1. This one. So what I'm going to do is I'm going to use z equals x plus y plus 1. And I'm going to plug in for x, y plus 1 here. And then for z, I'm going to plug in what it's equal to 8. And so in doing that, I'm going to get it, and I'm going to be able to get it in just terms of one variable. And so that's a strategy. So we'll be able to figure out what y is next. And y is what we were looking for. So we have 8 equals, and then instead of x, I'm going to write y plus 1 plus y plus 1. You're just substituting for what x is, and then you're going to add the rest of your equation. All right, so now I just have to solve this. So y plus y is 2y, 1 plus 1 is 2. And now I'm going to subtract 2 from both sides. So I've got 6 equals 2y. And divide off the 2 from both sides. And I'm going to get y equals 6 divided by 2 is 3. So it says the number of juniors is 3. However, we want to make sure that all of them are satisfied. So x equals y plus 1. So you've got y plus 1. You've got y equals 3. So you got x equals 4. So does it make sense? There is one more sophomore than juniors. So the sophomores, one more than the juniors. And that's correct. And then it says the senior is one more than the sum of the number of junior and sophomores. So 4 plus 3 is 7, plus 1 will be 8. Perfect. Just checking to make sure that the solution makes sense. And there you have it, a very basic general example of solving a system of linear equations with 3 unknowns. And I'm going to try to find maybe one more of these. They do get kind of complicated, but a systematic approach and the same kind of method of approach in solving applications, and yeah, you'll do just fine. Anyway, yeah, so I hoped that that helped someone out there, and yeah, I will probably go ahead and end the stream early tonight. I'm pretty tired, to be honest, and probably call that a win. And yeah, just try to figure out something to present tomorrow. And so trying to think if there's anything else that I want to talk about. That's the problem when you're doing math and you're tired, then you just I do math so much better in the mornings. So um, it's just not working out with my schedule right now to have a live stream in the morning. So um, maybe I'll get good at editing and just start like pre-recording videos or something. I don't know. But for now, I'm just gonna be taking it in stride day by day and trying to get used to um, being myself and being more natural for the camera. Anyway, I'm gonna stop rambling now. I'm very good at that, and that's a bad habit. So if you watch my video, thank you very much for watching it. I greatly appreciate it. Don't want to be in the way in case I feel like I'm right in the way. But yeah, and if you have an idea of something that you would like me to present, and give me some ideas to research and put together a mini lesson, that would be awesome because I feel like I would be more helpful that way. Just pulling random topics off the top of my head every day. It's kind of it. I don't know. We'll see how long I can keep that up. But anyway, yeah, I will be back again tomorrow, and I will see you all again next time. So this is me. I guess I'll sign off, and I will see you all again tomorrow. Bye.